Hello and welcome back to another episode of Math with Sohn. Today, we're going to be looking at some similar figures and how to solve for missing sides on them. So, a similar figure is really just two triangles or two shapes that are kind of identical. They have all the same angles, but one is just bigger or smaller than the other. And a lot of times they will call and give you a similarity statement, which is what this is here. Instead of it being congruent in the middle, it has this similar symbol, which is this little squiggly in the middle. And that means that triangle FGH is similar to triangle JKH. And with this, just like as if it was a congruent statement, we know the sides and the angles that are similar and correspond to each other. So angle F would correlate with angle J. Angle F would be the same as angle J because remember the angles are the same, it's the sides that are a little bit different. So these two angles are the same. Angle G would be equal to angle K, the one in the middle, angle G, congruent to angle K. And then angle H is, of course, equal to angle H because they're the vertical angles in the middle. Now, sides, we have FG is similar to JK. Those are not going to be the same. One's going to be smaller than the other. And GH, the next two letters, GH, would be similar to KH. And last, the H and the F would be similar to the H and the J. All right? So that is all that the similarity statement can tell you is what sides correlate. And in order to be able to set up the things that we will need for later, you will need to know which sides relate to each other. As a quick review, how do we find the scale factor? Well, you always find the scale factor by taking the new shape and divide by the old shape. So in this case, we're going from A to B, so that means B is the new shape, and A is the old shape. So we would take the 8, I'm going to take the 8, and divide by the 2, because those are the sides that relate to each other, which means 4 is our scale factor. And the next one, if we took the side, well, this is a little harder to figure out which side relates to each other. You can either look at the angles and determine, okay, this one has a double and a triple. Let's find the one that has a double and a triple. Or a single and a double. You can do it that way. The other thing you could do is just look at the side lengths in general. 4 is the shortest side. 10 is the shortest side. So you could link the 4 and the 10 up because of that. So in this case, I'm going to use the 4 and the 10, which are in between the double and the single hash marks on the angles. And new shape would be B over old shape, 10, simplify down to 2/5. All right? So that's how some of these problems are going to work. A lot of the other problems are going to be set up like a cross multiplication. So if I wanted to do number 6 for X and for Y, we would need to first set up our cross multiplication. You can set it up a lot of different ways. I like to set it up normally small shape over big shape just to be consistent. A lot of times it turns into left over right, but small shape over big shape will equal the small shape over the big shape. So let's recognize that AC is where X is. AC relates to DC if we look at the numbers. So small shape X over bigger shape, 28, will equal, pick any other two sides that you like that are relating to each other. The 6 and the 21 look promising because they're both there. So 6 over 21, small shape over big shape. And then all you have to do is cross multiply. So we are going to have to take the 21 and multiply by X, and that is going to equal the 6 multiplied by 28. Okay? So we have to do 6 times 28. Let's see what 6 times 28 is. It is 168. And then you would divide that by 21, and you'd be done. X would equal 8. So we found X. Now we need to find Y. When you have the problems that have you find X and Y, that just means that you have two separate problems, really. So I'm going to now solve for Y, and Y relates to 10. Keeping it consistent, I'm going to do the small shape over the big shape. The smaller shape is with the 10. So 10 over y would equal small shape over big shape, still 6 over 21. I guess we could have used the 8 and the 28 at this point. Cross multiply. 6 times y is 6y equals 10 times 21. 6y would equal 210 when you multiply 10 and 21. And then you just divide 210 by 6. And y would equal 35. All right. Going to do a few more quick problems right here at the end. And we'll be done for the day. So here we have small shape. Oh, actually, this is the small shape. But if you can't tell, you can do left over right. It's fine. As long as you're consistent, you can do small shape over big shape, small shape over big shape, or you can do the big over the small and the big over the small. You could do left over right. As long as you're consistent, you will normally be fine. So, x plus 5, that relates to the 9x plus 1. Those are the shorter sides of this triangle. Pn, first and last letter. JL, first and last letter. Small shape, x plus 5, over bigger shape, 9x plus 1. Will equal, keep it consistent, small shape, 14 over 49. We're going to have some cross multiplying to do here. 49 multiplied with x plus 5 will equal 14 multiplied with 9x plus 1. So we have to continue solving this by getting the 49 distributed and the 14 distributed as well. 49 times x is easy, that's 49x. 49 times 5, that's a little bit harder, plus 245 will equal 14 times 9, which is 126x, plus 14 times 1, which is 14. Continue solving this by moving the x's to left side or right side. It depends on your preference. I'm going to move the 49. Subtract 49x, subtract 49x. And then we would get 126 minus 49 is 77x. Plus 14 equals 245. So it's a relatively bigger equation than we're usually having. Continue to solve this. And we would have to subtract the 14 from both sides. And 245 minus 14 is 231 equals 77x. When you finally divide by 77, you get your answer, which is x equals 33. All right? So the equation was long, but the process was still the same. Small shape over big shape equals small shape over bigger shape. Pay very close attention to this one. We're going to have one example of it, and it is slightly different. If you have it set up like this, you have to first maybe draw out your two triangles. So if we were to draw out the two triangles, this would be what they look like. Here's the small one with the x plus 3 and the 52. Where's the bigger one? Well, it's the whole thing. The 2x minus 1 and the 91. Sometimes you have to add two numbers together to get this. Maybe it was 52 here and 48 there or something like that, and you have to add those two together to get the 91. They gave it to us this time. So once you separate those triangles out, either in your brain or draw it out would probably be the best move in the beginning, then you can do your cross multiplication. Small shape over bigger shape. X plus 3 over 2x minus 1 would equal small shape over bigger shape. A lot of these times the problems are just going to have bigger numbers. Don't panic, it's still the same thing. Cross multiply. 91 has to multiply with x plus 3, and that would equal 52 multiplied with 2x minus 1. So, continue distributing. 91x plus 91 times 3. 91 times 3 is 273 equals 52 times 2, is 104x minus 52. Continue to solve this. Subtract 91 would probably be my choice because 91 is smaller than 104, and that makes it not a negative number, but you could have subtracted the 104. We get 104 minus 91 is 15, I believe, 13. 13x minus 52 equals 273. Add the 52. Add the 52. 273 plus 52 is 273 plus 52, 325 equals 13x. Divide by 13, and we get our final answer. So divide by 13, x is equal to 25. Now, I don't know if you realize this, but I needed some scrap paper for that equation. It wasn't the geometry that was difficult, but the equation was a little lengthy. But we got our answer. We solved this equation. We set up our bigger triangle and smaller triangle relating to this, and we found our x, which was 25. All right? That's going to do it for this episode. Until next time, everybody stay positive, and I will see everybody later. Bye.